Now, regardless of brands, almost all TETRA terminals are GPS enabled. And by configuring it correctly, you're able to move your GPS data in through the radio and back out again into the TETRA cloud for analysis. Now, these can be set to be transmitted at predetermined transmission intervals, maybe every 15 seconds, every 5 minutes, every 300 meters, whatever that setting is. Not only that, your radio will take the GPS data that you have already collected and compress it to force transmission to the SWMI through the control channel in an efficient sort of a way, so they don't clog up the network with packet data, with data that you don't need. Again, if you've got software connected to the back of your network through to the SWMI, it becomes possible to have maps to allow you to collect GPS data and to display that. And you can collect your GPS time and position data for vehicle asset management, or AVL, personnel safety systems, emergency response, and many other applications. And if you were to add the RSSI, which is the received signal strength data from those packets, the GPS packets, it's now even possible to draw a live radio coverage map for the entire network. Now I want to talk a little bit about geofencing. Geofencing is the ability to create a virtual perimeter within the geographical area to identify objects that are inside, adjacent to, approaching, departing, or outside that zone. So for instance, here in this drawing, we've got a keep out zone. We don't want anyone in there, but out here in the green area is considered safe, so people can travel around. Now, using powerful GIS techniques, it's possible to selectively identify radio uses that are in some way linked to that virtual perimeter or geofence. So for instance, if someone is here entering that geofence, we can pick it up and advise that person appropriately. Or there might be a person leaving the geofence, going out of the geofence area. Armed with that information and powerful software again at the back end, we can actually signal to different radios. So if someone is driving carelessly or brainlessly into the keep out zone, you can actually track that trajectory and project where he's going to go and to tell him, get out of there because it's unsafe. Maybe it's a blast zone or some other thing that is happening, then you need to keep people out of harm's way. Now, superior radios is what we use quite a lot of at Radlink, so I've become very familiar with it. As I showed you this diagram earlier, short data service is part of the standard. But what Superior have done is that they've added an extra layer which I've haloed in blue there, what they call SDA, short data applications. In a way, you can think of SDAs as being like a web form on a small screen. It allows you to have a structured way to enter and to display formatted information on the screen. Now, the SDA technology that Superior have developed is tightly coupled to the Radio Manager tool, which they offered with their radios for programming and configuration. This so-called language is a method of creating an SDA, but unfortunately it's not really designed to be programmer friendly. Now, if you write software and you're from this particular generation, you probably find the SDA techniques is a little bit clunky. And so the time and effort required to build even a simple application can be very cost prohibitive. And there are very few people around the world at the moment who can write SDAs using Superior's proprietary techniques. So because at Radlink, the team of us who have to write applications want to be able to do it easily, we've actually created a new programming language and a compiler that will allow us to take a natural language or a programmatic language that we've created to be able to compile up applications to run on Superior radios. For those of you who are not software engineers, programming languages are here to model business and technical problems, and the programmer shouldn't be really worried about bits and bytes and how to move this bit from here to that byte over there. So we've worried about that by creating a language that's human readable. I've just taken a little snippet here on the right-hand side. It's very similar to C, C#, Visual Basic, other procedural type languages. It's designed for programmers so that you can allow yourself to be able to create code very quickly. The most important thing for us as software engineers is what we call code reuse, that we can take a chunk of code that we know works well in this situation, we can grab the whole lot, drop it into somewhere else, recompile it, and chuck it into the radio, and it will perform as we expect it to. The productivity improvement by using this method can be 10 to 1 or better. So what used to take 2 weeks to write takes only 1 day now. Here are some examples of what we've done in our samples of SDAs that are running on secure radios. Here is an incident report where you can select from a few buttons of what sort of spills you've observed. You can enter your employee number here because you're the reporting person. Here you've got a pre-start checklist. You're just about to pick up a piece of equipment and drive off with it. It's just a checklist to make sure you've done everything you need to do. So this is question 2 of 4. Have you cleaned the reversing camera? And then once you click yes, then you can move on to question 3 and so on. Or maybe you've had a pram and you want to record the incident. You can enter the vehicles that are involved. Or this is an evacuation order. If there's a storm coming, we can evacuate people to particular zones by sending them a written message with a timestamp so that it's an official message. And also the employee can respond by actually entering their own identity, and then they can say they're able to evacuate now or evacuating in 10 minutes. On their own, short data applications are useless. They're just like a static HTML page that you see on the internet. And it's necessary to have a back office application to actually handle all these interactions. So you send data out to the people in the field and you collect the data back from the field. Now I just want to introduce you to another piece of equipment that we've developed at Radlink. This is what we call the BBR Controller. Normally it doesn't come in a plastic case, but this is a show and tell version so you can see inside and see all the flashy lights inside. Basically it's a tool that we've created for the TETRA network to be able to send and receive data between pieces of machinery. And because TETRA networks have such an amazing signal coverage over large distances, although they don't have a very high data rate, it is still possible to move data around the network. And the key is to encode it in a way that will reduce overall network traffic and yet preserving the timeliness of delivery. Again, it's this whole concept of ours called Beyond Voice Radio. That's what the board looks like. There's a little bit of blurb on it. It's all in the presentation that will be available for download next week, I believe, from the Comms Connect website if you want to read more about it. But we're quite proud of the fact that we've squeezed on 2 CPUs. So this CPU here handles all of the digital I/O, all the communications, while this CPU here, coupled with its 256 megs of flash and RAM, allow you to run Linux. It's got an HDMI port for you to be able to see what you're doing. Most of the PLCs out there do not have HDMI capabilities. It's got 2 gigabit LAN, 4 USB ports, 2 RS-232 ports, CAN bus, RS-485, 4 relay outputs, 4 analog inputs, 4 digital inputs, 4 opto-coupled digital outputs. I think I mentioned CAN bus and RS-485 already. So there's a lot jammed onto that, and then there's a 32 gig micro SD card for storing data for retrieval after the event. Lots of peripherals, and we also are able to talk in a whole pile of different protocols to allow you to be able to interface with equipment that's already in the field. So there are lots of possibilities. You can use them for telemetry and SCADA, for logging data, for GPS logging, for higher sample rate than what your GPS offers, for event monitoring, triggering, and to connect equipment back to your back office over a TETRA network. What I've got here on this little table here is just a demo, just sort of as I wind up. I'm now talking to this little black box here, which is connected to 2 cyclone warning lights. I've only got 2 here. In our system, in a cyclone warning system, there will usually be 5. There'll be 5 different stages of warning, and we can control it either from the back office or from another radio that's been specifically permitted. So what I'm going to do now is I'm going to call that system and say, call me back. So I'm dialing it now, and giving it address. That second beep that you heard is the unit calling me back to say, I give you permission to touch things on the screen. Now what you will see is what I've got in front of me. Select the different warning levels. So now I'm going to select the red warning level, and then I'll hit the dial button, and I hope nobody here is suffering from epilepsy or anything like that. If you are, you might wish to turn away. And then if I want to turn on the green, I can do exactly the same thing again. So this is all controlled directly from a radio. It allows you to control a piece of equipment in the field without you actually having to go out there to do it. And at the moment I'm just using a pair of handhelds, so this is, I'll just turn it off before anyone starts twitching. Okay. Just to wrap up, traditional SCADA and telemetry techniques would not work with TETRA, so it's important that we need to intervene or interpose a piece of hardware similar to this to allow you to be able to handle the field equipment, so that the TETRA network doesn't have this overwhelming burst of data flowing through it. And here is just a simple example of what you can control. Maybe you've got a few lighting towers or some dewatering pumps. You can control, send all of that back to the TETRA radio network for control on a piece of SCADA telemetry piece of software, which our software will talk to. Maybe you run Cytect or Clear SCADA or GE Simplicity or one of the many packages that you can buy. We can allow you now to control your equipment in the field simply by adding a box like this. So in conclusion, there's a need to provide tools to enable managers, supervisors and safety officers to collect and distribute intelligence for vital decisions. Voice cannot do this on its own. You need data, so you might as well take advantage of what you already have on your network. Adding data creates a whole extra level of usefulness, like being able to turn on and off lights. And to be able to, for that data to be transmitted, you need to do it efficiently over the control channel. Creating well-structured data entry forms using SDAs allows you to have a rapid method of transferring information back and forth. Rather than typing the entire message, you can have them canned so that you basically say, I can evacuate, I can't evacuate, whatever. And SDAs can be used to send out time-critical information from the back office to the field, display in a human-friendly format. And this distribution can be automated. Completely automated, in fact. So, you've got a storm coming or there's a flooding starting, the system can detect that the flood level is increased so it can send out messages. Geofencing allows you to send out information on a location-specific sort of scenario. So what I'm hoping is that you have learned a little bit more about how you can enhance TETRA's data capabilities. And if you want to talk more about this or any of the things that I've mentioned, you're most welcome to grab myself or Nick, wherever Nick is sitting. Nick is there with his hand raised. Nick and I work together on some of these things, so we'll be able to answer some of your questions. So thank you very much for your attention, and the materials will be ready, I believe, within the next couple of weeks, because I know I've skipped through a few things pretty quickly. Thank you. Thank you.